Welcome to Mr. Getchak's online lesson on odd and even functions. Well, we're going to be going through odd and even functions. This will help you do this assignment right here, page 89, 99 to 101 odd, and 103 to 114 all. And we're going to quickly go through a quick lesson on odd and even functions. And we're going to try to figure out how to identify odd and even functions graphically, numerically, and analytically. Should be analytically. Analytically. All right. All right. Basically using algebra. Okay. So without further ado, let's go through this. Well, first off, identify odd and even functions. If you read through page 86 in your text, you identified that for odd functions, we have odd functions which have three distinct characteristics. Something that has to do with the odd portion, or the graphing, the algebra, or analytical, and numerically, which talks about a table. When you want to identify odd functions. Odd functions are special, okay? They're different than all other functions in that they have symmetry over the origin. Now, what is symmetry over the origin? Well, symmetry over the origin can be identified when you have, and I always think of an odd function, basic odd function, which is x cubed. Symmetry over the origin states that if you have a graph and you have x cubed, which looks like this, you have another one, goes like that, and whatever happens on the right side, the left side is going to be opposite. So if you plug in a positive value for 1, you get a positive 1. On the left side, you'll plug in negative 1, and you get out a negative 1. And that is applied to what we know about the algebra. If you had y equals f of x, all right, so if y equaled x cubed, all right, that's my function, all right, and I plugged in, let's say, f of negative x. I can identify this as an odd function if I would take and plug in negative x, and I would cube it. And if I realize that I get the opposite value for y, or the opposite of what my original function was, so in this case I would get equal to the opposite of x cubed, which in fact is the opposite of that, what I just identified is an odd function. We can also see this on a table in that we will see that we will have a point x in f of x, and we'll have another point which will be negative x, and then, or sorry, negative x, we plug in, we'll get a negative output, which is kind of identified right here. Now, that is what odd functions are. Even functions, on the other hand, are when we have a graph and we have symmetry over the y-axis. Now, over the y-axis, that is like a function like I always like to use x squared, like a butterfly. Okay? We have symmetry over the y-axis. We're going to have this right here, and we'll have a graph which is, all right, like the touchdown symbol, and what we have is x squared. So we have symmetry over the y-axis. Now, with algebra, unlike the odd functions, that if we have a y equals f of x, so y equals x squared, if I plugged in a negative x into this function, this even function, I should get out the same value as if I would plug in the positive. Nothing changes. Noticing right here, the negative x times negative x, because that makes negative x squared, would turn out to be just positive x squared. The same as the original function that we started with, all right, which is right there. Both when you plug in a positive value and a negative value, you get the same value out. Okay, and numerically on a table, you can see this by plugging in a positive x value, you get a positive y value in this function, plug in the negative, just the opposite, and it's going to get the same value out. Right? And that gives us a symmetry over the y-axis. Okay? So one thing I always remember is that odd functions, start with the O, are symmetrical over the origin. Even functions have a v in it, and that v is symmetrical over the y-axis. So, symmetry. All right? Now, how can we identify these? Let's go through a couple examples. First off, we'll talk about examples of even functions. Now, in order to figure out an even function algebraically, we're going to try this out, is that we can plug in a negative x value in here. And that's how you identify this algebraically. According to even functions, if I plug in a negative into the original function, which is this right here, if I get out the same function as it began with, okay, after I simplify, I will have an even function. Okay, that means it has symmetry of the y-axis, and it has all the other characteristics of an even function. So that's what we're going to do. We're going to plug in negative x into this function. What happens is, what we have is, well, negative x squared is x squared. We have minus 5. And we begin to have the same value as our original function. It's the same equation. Therefore, we have symmetry over the y-axis. We can verify this both graphically and numerically. That means using a table. So if you would put this in your calculator, you would a graph like this. Notice how you have the symmetry over this y-axis. Whatever happens to the right side is its symmetrical partner to the left side. Okay? The numbers. If I plugged in a positive 1 right here, okay? If I plugged in a positive 1, I got negative 4. If I plugged in a negative 1, I got negative 4. The same outputs occur. Same thing happens for 2. I get out negative 1. I plug in a negative 2. I get out negative 1. All the same outputs occur when you plug in the opposite input. Now another one, which is a little bit more difficult, is what we have here is h of x. Now this is a rational function, so it's a little bit more complicated, but we'll try it out. We'll see what happens. When I plug in my negative x value into this function to find out if it is some symmetry over the y-axis or if it's an even function, I'm going to take negative x and I plug it in there and I square it. Oops, I'm going to subtract 5. And I'm going to do the same thing and plug it into these two values because that's how functions work. Substitution. And what we have then is, when we simplify, we should have the value, well, negative x squared is x squared, so we have x squared minus 5, the same as we have at the top, all over, all right, x to the fourth, because negative x times negative x times negative x times negative x is x to the fourth, and then we have the, once again, negative x squared, which is x squared. So h of negative x is the same equation as the original. Therefore, it is an even function. If you graph this, you would identify that it has symmetry over both the y-axis. All right, so this graph has symmetry. And you notice that if I plug in the opposite values, so I plugged in 1, I got negative 2. I plugged in negative 1, I got negative 2. Same values outputs. I plugged in a negative 3, I get 0.044. I plug in a negative 3, I get the same output. So from all that material, from all those observations, we can identify both algebraically, graphically, and numerically that this is, in fact, an even function. So even functions, you plug in a negative, you get the same out. It has symmetry of the y-axis.